The idea of extraterrestrial life has always fascinated people. But the possibility of extraterrestrial life and the hope of its discovery has led to incredible advances in this area in recent years. The discovery of oceanic moons with volcanic activity in our solar system and the discovery of multiple extrasolar planets in the orbits of other stars have revolutionized the search for life in the universe and suggested potential habitats for different types of life. Traditional theories say that life originated from a raw soup collected on the surface of the primary Earth in warm, shallow, chemical-rich seas. This assumption seems to provide the ideal conditions for the presence of the three necessities of life: basic carbon chemicals, water, and the source of energy from the sun. Today, scientists also believe that the presence of carbon and water is essential for forming life. Because the presence of these two substances makes it possible to create more complex chemical compounds. But the discovery of Extremophile has led to a change in the concept of life and the conditions necessary for survival. Extremophiles are living organisms that feed on chemical energy and survive in complete darkness in deep-sea volcanic craters and even deep reefs beneath the Earth's crust. Every possible life form must survive through a set of chemical reactions known as metabolism. Over time, this metabolism inevitably changes the environment and conditions of the planet where the living thing lives. For example, oxygen under natural conditions is a passive chemical stored in the form of mineral compounds inside rocks. It is not found in an open environment. Had it not been for the evolution of life and the billions of years of metabolic reactions of plants and photosynthetic algae, there would have been no oxygen in the Earth's atmosphere. Accordingly, oxygen in the atmosphere can be considered a potential chemical biomarker of the existence of life in other worlds. Astronomers have so far measured the chemical composition of the atmosphere of several extrasolar planets. But future telescopes will make that much easier. Some astronomers have speculated that not all life forms on Earth need to be done from the beginning. They say life itself, or at least the complex chemical compounds that help start life, may have been moved between planets by meteors or comets. Tardigrades, for example, are small animals also called blue bears. The stability of these creatures shows how life can survive in conditions very different from those on Earth. Tardigrades can survive very high or shallow temperatures and pressures, being in a vacuum and bombarded with high-energy radiation. Astronomers believe that the most prone planets to host life around any star are Earth-like planets within the habitable zone, around the host star, where the temperature is sufficient for liquid water to flow on the planet's surface. Several worlds have been discovered in recent decades, and these types of livable planets seem abundant in the Milky Way galaxy. One of these planets is Gliss 581g. In 2005, NASA's Cassini space probe discovered huge columns of ice and water that erupted from the surface of one of Saturn's small moons, Enceladus, indicating the existence of a subsurface ocean. The heat from the powerful tidal forces kept it fluid. This finding makes Enceladus one of the possible hosts of life in the solar system. Or in another case, methane gas is produced only by inactive volcanoes or living microorganisms. The chemical composition of methane is rapidly broken down when exposed to the sun. For this reason, recent discoveries about the presence of methane masses in the planetary atmosphere of Mars have raised exciting questions about the existence of possible life on the surface of Mars. On the other hand, the Extraterrestrial Intelligence Search Project, known as SETI, uses various methods to track the signs of potentially intelligent aliens in the universe. The most common method is searching for artificial radio signals in the sky. But such signs can only be detected when they have been deliberately transmitted to us by strangers. Another alternative involves looking for signs of technology, such as pollution in the planetary atmosphere or even unusual changes in stellar radiation resulting from the engineering achievements of space aliens. Estimates of the existence of intelligent civilizations in our galaxy vary widely. Some estimates suggest several million more civilizations, while others estimate only one civilization.